The following is a presentation of the Six Arrows Radio Network.
Episode 55, Ham Radio 360 Podcast, IMS, big announcements and more coming up.
CQ. This is AB4WS, Alpha Bravo 4 Whiskey Sierra, Jack Prindle in Big Bone, Kentucky, and you're listening to Ham Radio 360 Podcast. 73s, everyone.
MTCRadio.com presents Ham Radio 360, the podcast, with your host, Cale Nelson, K4CDN.
So it is episode 55. I'm your host back with you again, Cale Nelson, K4CDN. Hope that you all had a marvelous field day experience this past weekend. It was hot in places, stormy in others, but hope you and your club or you yourself at home had a great time operating on the bands. Yeah, my name's Cale. I do this every other week. It's what we do. We've been podcasting for about 2 years about amateur radio. And if you're new to the hobby, interested in the hobby, or been involved in the hobby for the last 37 years, we've got something for you, I guarantee you. We're going to prove that here in just a little bit as we get into the IMS conversation with George, David, and Barrick, so you don't want to go anywhere. But first, let me recognize our show sponsor who's been with us since before we even recorded our first episode, and that's Main Trading Company, and you can find them online at mtcradio.com. Richard and Christine Lenore have built a pretty phenomenal mom-and-pop small business down that way. They've got some great help, too, might I add, Tammy and Danielle there in the shop. But I got to tell you guys, if you're looking for some gear, now's the time to buy. In addition to all of their used gear, which is just everywhere in the store, they're also one of the top sellers of ICOM gear on the planet. You're looking for an all-band, all-mode rig, maybe a 7100, they've got them in stock. They've got new stock, they've got V-stock repacks. They've got your ICOM gear that you're looking for in stock right now, and you can find it at mtcradio.com. Yeah, so I hinted at the beginning of the show that there's a big announcement, and I'm not going to wait to the end. I'm going to let George and then finish out the show for me here in just a minute. But I want to make an announcement here to all of the listeners. This is going to make some people really, really happy. Let me start it there by saying, since the beginning, this has been a bi-weekly podcast. I intend to keep it a bi-weekly podcast. But we've got a lot of folks who ask us, will you please give us more? We want more of Ham Radio 360. Well, we're going to give you more Ham Radio 360 with a twist, and I'm going to kind of share that with you right now. Beginning next Tuesday, which is normally the hamradio360.com podcast week off, there'll be a new podcast launched, and it will be an umbrella, a side project, a mini series, if you will, that will be on this same RSS feed. You're not going to have to go find it in iTunes or in your podcast player. When the new episode releases, it will release right here where you're listening, okay? And if you don't know where that's at, you can go to hamradio360.com and you'll find what we're talking about. Now, what are we doing? We're going to launch a brand new podcast mini-series, and we've got a lot in mind on this, but we've at least got 10 shows figured out in the direction that we want to take those 10 programs to begin with. So we're going to launch this new mini-series, and it's going to be really focused on hands-on DIY radio topics like building your own stuff. So if you've got some friends that are makers that you really can't get them into the hobby, they may like this. If you're somebody that likes to build stuff or experiment, you're really going to dig it, and it's going to be a lot of fun. Now, why in the world are we doing this? Well, I'll tell you why, because as we've been going through this process of 2 years of growth and building our brand and getting to know you guys, we have a lot of interest in the DIY field. A lot of people want to build some stuff. They want to do it themselves. That's kind of like making a resurgence, if you will. Maybe it never died where you are, but in some places it's gone away and now it's coming back. So we're going to focus on the DIY. We had such tremendous feedback on our microcontroller embedded Linux show and other shows that we did that were kind of deep and went down that road. Your response was so massive, we knew we had to bring you something else, and that's what this is this has been sponsored, or not sponsored, totally wrong word. That's where this began. That's where the growth began for this. We want to foster and build up more hands-on work in the amateur community because that's where it all got started, and we're hoping that you'll embrace that and participate with us as we go down this road. And we also want to go deeper than what we can do every other week when we have our interview shows here on hamradio360.com podcast. So this is going to be a complimentary podcast to the normal Ham Radio 360 podcast. And what's going to be cool about it is we're going to alternate the Tuesdays. So this week you're getting hamradio360.com podcast. We're doing the IMS show with George, David, and Barrick from California in just a few minutes after we finish the announcement here. And then next week it'll be episode 1 of the new Workbench podcast. That's what it's going to be called, Ham Radio 360 Workbench Podcast. The Workbench, because that's what it's about. It's about working on your bench, building and working on stuff. It's going to be a lot deeper. The topics are going to be more involved, probably going to be some building, some build-alongs, and I have a feeling this will probably turn into some stuff even greater than what we think it's going to do right now. So we're going to do this on the opposing weeks of this show. That means from now, for at least the foreseeable future, every Tuesday we'll be releasing a program. So you guys who want your Ham Radio 360 fix every week, you've got it, okay? It'll start next week. George and Jeremy are going to take this one on. This is their baby. This is their brainchild. This is what they are working to create for you. I will be there maybe in the intro show. I may come back and stick my head in every once in a while. But George, KJ6VU, and Jeremy, KF7IJZ, this will be their show, and they will be your host for the program. Really excited about it because George and Jeremy are a lot smarter than me, and they make those technical things easy even for me. So I know you're going to dig it. Now, in addition to that, George and Jeremy as your host, we have a show sponsor for the mini-series, and that's Eagle PCB Design Software. If you guys aren't familiar with that, you will be, because they are the new show sponsor for the Workbench podcast. They're going to have advice. They're going to do interviews. They're going to do build projects. They really want you guys to do a lot of Q&A with them. So go ahead and start thinking if you've got builder, maker, questions, DIY ideas and stuff. Go ahead and start getting those to them. You can email them, George at hamradio360.com, Jeremy at hamradio360.com. They want to hear from you, and they could probably use some encouragement as well. There's a lot of work to do this. I mean, there's a lot of work to do what they're starting to do. It's going to air every other Tuesday. So you'll have this one on a Tuesday, and you'll have their show the following Tuesday, which is really exciting. That means every week of the month, you'll have a new Ham Radio 360 podcast to listen to. And again, they want show suggestions for topics. They want your Q&As because they'd like to have a section of their show dedicated to Q&A with the listeners, fellow hams, and upcoming makers, builders, and whatnot out there in the blogosphere, podosphere. I'm not sure what you would call that, but we're excited. It's the Workbench podcast. It's going to premiere next week on this same bat time, this same bat channel, and it's going to be a lot of fun. George and Jeremy are working really hard to make it awesome for you, as you know they will. So make sure you're telling your friends about it. The Workbench podcast is on the way. BridgeComSystems.com is your place to buy your 220 amateur radio gear. Handy Talkies. They've got mobile radios now. They've got repeaters for all frequencies. Land mobile radio, too. If you have a need for a repeater, a mobile radio, handheld radio, make sure you check out our friends, BridgeComSystems.com. So just a few weeks ago, I was in Dayton, Ohio for the Big Hamvention along with Jeremy and George. We had a great time. Thank you all that we got to meet and for sending me there and etc. But while that was happening in Ohio, in California, they were having a great time at the Maker Faire. And following the Maker Faire was IMS. So what we're going to do, we're going to bring George in here in just a sec, and we're going to turn it over to him. George is going to talk to David and Barrick, and they're going to talk about Maker Faire, and we've got the conferences from IMS to play as well. So it's going to be a great show, a lot of fun, a lot of stuff to learn here, because there's a lot of questions about how do we get amateur radio into the youth's mind, how do we turn the youth onto ham radio. There's a lot of that spoken of here directly and indirectly. So I hope you enjoy the show. George, welcome in and take it away.
Hey, thanks, Cale. This weekend, in addition to the Dayton Hamvention on the West Coast, is Maker Faire in San Mateo. The San Mateo Maker Faire event is the largest Maker Faire in the world. And it's just north of the center of Silicon Valley, so it gets a great draw. Well, this year at Maker Faire, our very own Bayonet Radio Club was part of the ham radio scene happening at Maker Faire, and David, W6DTW, and Barrick, K6BEZ, were both very active in organizing and promoting amateur radio, and we're going to talk to them in a few minutes about what happened at Maker Faire. Turns out the same week, starting on Monday, is a professional event called the International Microwave Symposium, IMS. And IMS is put on by the IEEE, and this is a professional microwave and RF event where there's lots of papers, there's a trade show, and there's special events. This year, there's a special amateur radio gathering and a panel discussion. The panelists are university professors who got together to talk about how they use amateur radio in their classrooms. So in addition to the interview that we have here with David and Barrick on both the Maker Faire and IMS, we'll also have the IMS panel discussion about amateur radio being used in the universities. So let's jump right in and start with Maker Faire in San Mateo, California. So thanks for joining me. And David, why don't you start out and tell us a bit about the ham radio presence at Maker Faire?
The ham radio at the Maker Faire is something that we've been doing for several years. The last 4 years, the Bayonet Group has had a booth, and we have done various projects over the course of time. Last year, we built HF antennas as part of the Nepal earthquake relief effort. This year, we focused on software-defined radio and really trying to make the technology of amateur radio accessible to non-hams. So it was not really focused on amateur radio technology, rather on things that people without licenses could do in the hopes that they would then take an interest and ask about getting licensed.
So what was the turnout? Was there a lot of interest in this kind of topic, or was this just another thing amongst many different maker kind of topics at the event?
We had great turnout. The booth was busy all weekend long. Saturday and Sunday were nonstop. And I would say that at any given time, we had 4 or 5 people working the booth. And it was very hard to find time to take breaks. We were working through our lunch hours and having long conversations with people. It was really a phenomenal presence. And I really think that a lot of people got exposed to radio technology as part of what we did.
So describe the booth. Tell us a bit about what was shown in the booth and what drew the audience to you.
So last year we noticed that there was a lot of interest in the software-defined radio exhibit, which was frankly a small corner of what we were doing. So this year we decided to focus on it completely. We had a 30-foot booth with 3 tables, and the one table was really about core technologies. How do you implement an RTL dongle on a Raspberry Pi or on an Android tablet? And it was really sort of a how-to to make the technology work. There was a booth that talked about applications. We had everything from APRS trackers to APRS-enabled radiation monitors. There was a satellite tracking system, and all of it was microcontroller-based. We didn't bring a PC for any of these projects. Then on one table, we had a high-end software-defined radio, which were actually commercial software-defined radios that had been loaned to us. And they were sort of this is, if you were really interested in software-defined radio, you had commercial implementation. You could have a conversation with somebody about that. So it really showed the flow from a very basic NULEC or RTL SDR dongle all the way up to an Edis research platform.
So how does that tie in with ham radio? So obviously you could use some of these devices as a ham, but when you're there as an amateur radio club and showing the technology, was there a clear tie-in to ham radio?
I really think that there was. One of the things that we showed was the creation of basic test equipment using SDR dongles. For example, spectrum analyzers on an SDR. That's something that normally you would pay thousands of dollars for. Whereas nowadays, with the advent of these microcontrollers and these dongles, you can create a spectrum analyzer for under $100. We have cable sweeping technology. Barrick, K6BEZ showed a wideband noise source sweeping into a filter, which was then being shown on a spectrum analyzer, and it was being used to analyze this filter. With a directional coupler, you could make an antenna analyzer from that. So for less than like $250, you can really build up a very nice suite of test and measurement equipment that I think any ham would want to have in his kit.
So when you look at the other folks that were displaying at Maker Faire, other amateurs, what kind of other things did those folks do?
Well, the folks from the 50 megahertz and up group in the Santa Clara Valley were there, as they always are. Wayne and Brian and those folks were there doing their display, and they were showing a lot of 10 gigahertz radios, microwave radios, some SDR as well. So there was some overlap there, and they do a fantastic job at the Maker Faire every year, and we're really happy to partner with them. And what we've created at the Maker Faire is what I like to call Radio Row, which is 60 linear feet of space, which is all dedicated to amateur radio. There was another group that was outside doing emergency communications, comm van, kind of like a BlackBerry React or a CERT. And then there was another group that was there, Mikey NE6RD, who was testing. So they licensed, I want to say, 25 people. They tested at least 25 people at the show, and 25 people got their license. And they took the test on the show floor. So that was great.
So it sounds like that there's a big turnout. I mean, Maker Faire is enormous. The Maker Faire in San Mateo is the biggest one, I believe. So there's a huge turnout, and you would think that the kind of folks who would come to the Maker Faire would be a great target for potentially being amateur operators. So when they came by and they look at this, I imagine some are interested in the technology in general, but some are interested in getting their license. Do you think this is a good kind of outreach platform to reach people who might want to become hams?
I really do. I think that a lot of people came by and said that, I've seen these dongles before, but I never really knew what to do with them. Some even said, I bought one, but I haven't even used it yet, and I don't quite know exactly what I'm supposed to do. So how do I make it work? We were showing software packages on Linux platforms, and so GQRX was a common platform. GNU Radio Companion was running on some other platforms, and it was really nice to be able to show people kind of a how-to get off the ground with their dongles that they already owned. And then we had a number of people who went through the testing, and as soon as they were done with testing, they jumped over to our booth and were like, okay, I just passed the test, now what do I do? And that was great. And we had a few people who even came in and said, if I got my license, what does that buy me? The band plan handouts that we had were gone in like the first day. I mean, people were just taking the band plan because they were like, wow, I had no idea I had so many frequencies available to me. And then they would go next door and say, okay, how do I test? So I do think that soft sell approach, rather than saying, we're pitching amateur radio, you should get your license. I think that really worked, and it really brought a lot of people into to interest. And I hope that we're going to have a few people next year who will come back and say, I got my license because of your booth.
So that's a great approach, because you're not saying, hey, we're ham radio, and the person walking by might say, well, I don't really care about that, but the SDR and other technologies really draw them to it. So that does make a lot of sense. So, Beric, what was your experience at the Maker Faire?
What I want to say about the draw for new people, we had a lot of lapsed licenses, and they said, I got my license a long time ago, I should do something with it. But the other one was people were they didn't want to spend too much on their equipment, and that's the traditional, you must spend so many $1,000 on a rig. Seeing that what they could do with a $20 dongle and a $20 noise source, replacing a multi-$1,000 piece of test equipment. Some people got that, even though they weren't necessarily radio-based. So I found Maker Faire a lot to be what you can do with not much money. And now they know they can get involved in radio and play with radio for not much money at all.
So speaking of projects and being able to do things with not much money, and David alluded to this, so some people might recognize your call sign because you worked on a project in the last couple of years that got a lot of publicity on the internet, which is an antenna analyzer project. And I'm curious if that's something that you were showing there, or do you think that would be a good kind of a demonstration at some point?
Well, I actually showed it last year and the year before. I didn't show it this year. And it wasn't really much like the filter using the noise source and the SDR. They're all good demos. And yeah, I should have taken the antenna analyzer along as well, but you've only got so much table space.
So when you look at Maker Faire for next year, do you have any plans at this point to participate again? And if so, what direction do you think you would go next time?
I think my feet are still sore from Maker Faire, and then we've got IMS to go through, and we've got Field Day. So, and then Pacificon. So, and we're going to do Baycon again, right? So I haven't even begun to think about what we're going to do, but I would definitely like to do more on the SDR front, and I think Barrick has some ideas as well. So we're going to be talking about those.
Yeah, that sounds great. And Barrick, what do you think?
Well, we kind of got a bit fortunate last year. When I say fortunate, they just had the earthquake in Nepal last year, and then we were building antennas for use in Nepal. And then we were doing SDR, including plane trackers. And then, like the day before Maker Faire this year, that plane went down in the Mediterranean Ocean. So we could kind of tie that in with our ADSB tracking.
That seems like a hot topic. I never even heard about that till Dayton. And there's people with these SDR dongles plugged into Raspberry Pis, sprinkling them across the country to track all this information.
Well, that seems to be the stereotypical first thing you do with these SDRs when you buy them, and you don't actually need a license to do it. It's easy to set up, as cookbook recipes for that. And you can even get a free Raspberry Pi and a dongle from Flight Tracker, I believe. Because if they want coverage in your area, then they'll send you the Pi and the dongle.
And then they pull all that data and aggregate it together, and then that's available for somebody to use, I suppose.
Yes, Flight Radar. And if you go and type a tail number in there, they'll tell you where that plane is and things like that.
So, David, tell us a little bit about the people that you had there in the Bayonet booth at Maker Faire.
So this year we recruited a great team, and we had a huge number of volunteers that were part of it. Interestingly enough, everybody who we had recruited for Maker Faire this year, I would say was probably 35 years or younger. So we had a very young booth. We had people who were former students at Carnegie Mellon, Silicon Valley. We had people who were former students from Cal Poly San Luis Obispo, and because of that, I think part of it was that they related to the makers, because the makers tend to be younger, and so we in some ways I think we're a little bit more approachable in that, and these are people that are doing really interesting work with pies, and they're not afraid to get their hands dirty, and they're not afraid to blow something up and try again, and so I think that that maker mindset really manifested itself in the team, and I want to thank my team for being part of the fair this year. They were phenomenal, and they put in a lot of work. It wasn't easy, but we pulled it off, and so they did a great job.
So it sounds like some of the keys to success there are to have young people that the potential amateur radio operators that are younger could relate to, and doing things that are the kinds of things that would attract someone to our hobby.
I agree with that. I think that if we're going to really keep the hobby vital and move it into the 21st century, we really have got to begin to bring those younger people forward. And so, if you're given a choice between putting somebody in your booth who's a millennial or not, then I would sort of think that you'd want the millennial in the booth, because those younger people are going to be a much more comfortable approaching them and coming into the booth and going, hey, you know, it looks like you and I went to school about the same time. What's this ham radio thing all about, and why are you involved? I see your dad standing over there, right? But I understand why he did it. But why did you do it?
That's great. Well, thank you so much for giving me the recap on Maker Faire. It sounds like it was a really, really positive experience and a really good turnout. What I'd like to do is shift gears and talk a bit about IMS. So this weekend in San Francisco, California is the IMS show, the International Microwave Symposium. So David, tell us a bit about IMS and what it's all about.
So the International Microwave Symposium is a major conference of the Microwave and Theory and Techniques organization, which is part of the IEEE. And the IEEE is the International Electrical Engineers Organization. The MTT is the big show that rotates around the United States, and every 10 years it comes back to San Francisco. And it also co-hosts a couple of other conferences, including the RFIC and the ARFTG conferences. But it's really just a massive turnout of all the microwave and RF folks that are in the Silicon Valley, and frankly from around the world, that they come here for this event, and it gives everybody an opportunity to go to papers, panel talks, discussion sessions. There are some plenary sessions. There's some standards work that occurs. There's an expo, a big show floor full of vendors that are all showing various components and solutions for RF and microwave. And what's interesting, of course, is because many hams are also involved in the RF and microwave industry, so we do get a lot of hams that come to the show. And so we do have an amateur radio component to the show where there's a panel and then a social, which is occurring right after that, and that's happening tonight.
So the panel discussion is going to be really interesting this year. And I know both you and Barrick are involved in organizing the panel and getting the speakers and setting the theme. So tell us a bit about what the panel is focused on and who some of the presenters are going to be.
The panel is going to be focused on the use of amateur radio in the university as a tool for teaching. And this is an outgrowth of a trend that we've seen in the United States where it used to be, like when you and I went to high school, there was a lot of shop classes. So you had wood shop, electronic shop, metal shop. There was a lot of hands-on. And it was sort of like what the Europeans have with a, sort of a trade high school. No, we don't do that in the United States anymore. I mean, a lot of high schools have just completely given up shop. And so what happens is that younger people don't have those hands-on capabilities like they used to. And what we're seeing in the industry is that when you are applying for a job, the job description often says, bachelor's degree required, master's degree preferred. And what's I think has become is that the bachelor's of electrical engineering has become like the basic job requirement. It's what the high school diploma used to be. To get a job, you need a bachelor's degree in electrical engineering, and if you want a really good job, you probably better have a master's or even a PhD. But because the way that academia works, those degrees, those advanced degrees, are really more theoretical. You don't get the hands-on practical knowledge. And so what we're doing is we're graduating master's students who, when you sweep an inductor with an RF generator and measure the output, and you ask a master's degree student, well, what does the response look like on a spectrum analyzer? He wouldn't be able to tell you because he hasn't touched anything in the time that he's been in school. It's been all theory. It's on the screen. So the amateur radio has really become the way that colleges are beginning to teach that hands-on, those critical skills that are necessary for really building real-life things. So what we're doing with the panel is that we have 4 professors from 4 universities that are using amateur radio as a tool to teach their students practical knowledge. So the 4 professors that we have are Dennis Derrickson from Cal Poly San Luis Obispo. And Cal Poly is a very well-known hands-on school that just does great practical teaching. University of California, Davis, Dr. Leo Liu, and Davis has been implementing and has for many years been a very practical school. I went to Davis myself. And they've continued that tradition and have become very powerful in the RF and microwave field. Dr. Bob Iannucci from Carnegie Mellon University, Silicon Valley, and he's a very practical person. He used to be the CTO of Nokia. And these professors are all hams, and they're using amateur radio in their curriculum. And then we have Dr. Sanjeev Pandey from the Institute of Engineering at Tribhuvan University in Kathmandu, Nepal, who is also using amateur radio in Nepal as a way to teach his students. And so tonight's panel is really going to be them talking about how that has applied to their curriculum, what benefits they're seeing, how have their students been doing over time, has it affected their ability to get jobs, have they been more successful in their careers because of that practical knowledge.
So I know for Cal Poly, as you mentioned, they've been very active in the amateur radio world. They've got an active ham radio club, and I believe if you're a double E student, I don't know if you have to get your ham license, but it's encouraged, isn't it?
Some projects at Cal Poly, the practical projects like the senior design project, are based on an amateur radio technology. So if you take the senior design project at Cal Poly, you are required to have an amateur radio license. So, I sometimes I jokingly refer to it as the Derrickson doctrine, that, if you're going to come through Cal Poly, you're pretty much going to graduate with an amateur radio license. And I think that, we saw at the company that I was at recently that we had a lot of Cal Poly graduates there, and they were very successful. I think they really knew how to build real stuff. And so I think that the Derrickson doctrine really works.
Well, I know for me personally, whenever I learned something in school, if I could somehow relate it to the experience I had as a young ham radio operator, understanding standing waves or even just basically Ohm's law, if I had some practical experience, it was so much easier to understand the theory behind it that it seems like it would also help in the comprehension of the students for the material that they're studying.
I really do think that it does. I think that when you come into an engineering curriculum, especially today, there's so much technology now. I mean, when I went to school, it was overwhelming. I can't imagine what it's like today with the amount of technology that we've developed in the 2 decades since I was in college. It's really been an expansion. And so how do you relate that to things that you understand? How do you make sense of it all? 4 years is not enough time to get an electrical engineering degree. Realistically, I think that 4 years is probably not enough time. 5 years for an electrical engineering degree is probably about right. And you have to frame it around something, or else it's just like drinking from a fire hose. And so I think what your experience is exactly right. If you have some level of hands-on experience that you can say, I remember, that's why my dad was always talking about standing waves. That's what VSWR really means. Then I think it clicks.
There's a local high school here, Valley Christian High School, and they actually have a subject called satellite tracking. They don't mention amateur radio, but you go through it and you end up with your extra amateur radio license because they take you all the way through from beginning to the end. And amateur radio is not even mentioned, but it's towards the goal of doing something called satellite tracking.
Harkening back to the discussion about the Maker Faire, where the approach might not be explicitly, here's amateur radio, come learn about it, where if you went to all those kids and said, do you want to come to the ham radio class? Maybe a few would. Perhaps in that case, if you said, hey, come to the satellite tracking class, they'd probably get more takers.
Yes, not mentioning amateur radio, which is kind of considered old and Morse codey in some people's minds.
Hey, I like Morse code.
Yeah, but that shouldn't be the gateway to people getting their license. I mean, I'm an extra myself, and I wouldn't have got my license back here if I needed my Morse code. It just didn't really interest me.
So if you had the Morse code club in college, you probably wouldn't have done it?
If Morse code was a requirement for ham radio, I wouldn't have done it. But I'm a radio frequency design engineer by trade. So there are other parts other than just Morse. Look at the 50 megahertz and up people.
Yeah, very good point.
Well, I think I think what Barrick has said is really true. You have to tune amateur radio to the personalities or the care-abouts of younger people.
Surprisingly, things like contesting, field day, we get a great turnout on field day because it's a contest. There's a little bit of competition involved, and they kind of want to outdo each other in scoring points. Or things like a balloon launch where you're going to see how high can it go and how far can it go, and that's exciting. So that is sort of the entry path, I think, for young people to get excited, and then eventually they'll find other things to do in the mainstream of the hobby, but those might well be the things that really trigger the interest.
And, my oldest daughter has her license, and she uses it in lieu of a phone. So we don't give her a phone, but she walks home from school, and she uses the radio to call us to let her know where she is. And your sons, George, were, both licensed, and I know that one of them, in fact, went to Cal Poly. And I think your experience with them, and I would imagine that you have some stories as well about how their licensing helped them in their schooling as well.
Very much so. It really echoes what you said. So their interest really was triggered by field day because they like the camp out and they like the competition. And if they could one-up their buddy that's at the next table on the, on the other band, then it's really a lot of fun. And my older son, as you mentioned at Cal Poly in engineering, even though he was doing biomedical engineering, not electrical engineering, but of course you do electronics. And when he hit the electrical engineering classes, for him it was easy because he'd already seen the basics. He'd already seen Ohm's law and power and how do you calculate a resonant antenna and all that. So for him, all that kind of came back as familiar territory. And so that gave him a little bit of extra confidence in approaching those subjects. So I think drawing young people in, finding a clever way to do that in a way that's compelling to them, because it's their generation, they'll make of it what they will. And perhaps along the way they'll find some of the old things that we like too, like CW and PSK and other things like that, and that will come in due time. I want to thank you both very much for your time. I know it's been a really busy week between Maker Faire and now here at IMS in San Francisco. So with that, thanks very much for joining us, and I hope you have a great time here at IMS.
Thanks very much.
Thank you.
The Kenwood gear stacked high down at Main Trading Company, and it's not because people aren't buying it. They just keep that much of it in stock because they're selling that much of it. If you're interested in some new Kenwood gear, you need to check out mtcradio.com. Call Richard Christie, Tammy, or Danielle. Let them know you heard about them here on the Ham Radio 360 podcast. Get your Kenwood gear at mtcradio.com today.
Hi, Dan, KB6NU here. You know, there's always been a bit of a mystique about operating CW, and sometimes it's difficult for newcomers to literally crack the code. Well, that's what my book, The CW Geek's Guide to Having Fun with Morse Code, is all about. Written in my no-nonsense style, it's full of practical information that will help you have fun learning and using Morse code, including how to choose a key, how to tune in CW signals, how to make contact, and then what to do once you've made contact. Let the CW Geek help you have more fun with Morse code. Go to kb6nu.com/CWGeek and get started today.
So now you're going to hear the university professors panel. The audio is a little bit difficult to hear because it's in a big conference room, so you'll have to listen closely to what they're saying. This runs about an hour, and we hope you really enjoy it.
So this is a topic that I've been interested in for several years. I work with a couple of universities in the course of my career, one of which is that I'm on the Carnegie Mellon University Silicon Valley Dean's Advisory Board. The other is that I'm on the Industrial Affiliates Committee for University of California at Davis, which is where I got my degree, go Aggies. And I have been interested in the topic of amateur radio in the university simply because I believe that we're seeing a shift in the way that education is being taught in the United States. It used to be that high schools were, in a way, they were like technical schools or trade schools, and similar to what we have in Europe. You learned wood shop, metal shop, auto shop. There was electronic shop. I got started in amateur radio partially through my family, but partially because my school had an electronic shop. And now I think we are reaching a point where, unfortunately, we're preparing high school students to go on to study, to get graduate degrees. And it's not surprising that we're doing that, because if you look on any job posting for any of the companies that are in the Silicon Valley right now, what does it say? Bachelor's degree is required, master's degree preferred. So we're putting a lot of pressure on college students to move on into graduate programs. And that may be a great thing for some people, but unfortunately I think we're also removing that hands-on requirement that is so important. I go to the Maker Faire every year. In fact, I'm still really tired from last weekend. And one of the people that I talked to is Jerry Ellsworth. Does anyone know the name Jerry Ellsworth? If you do, raise your hand. So Jerry Ellsworth is like the queen of the Maker Faire, and she's the sort of almost the face of the Maker movement for some people. And she's working for a very interesting company right now. She said the biggest thing that she's facing hiring right now is not the availability of candidates. It's that when she asks a candidate, okay, you have a swept frequency generator going into an inductor with a load on the end, and you're measuring the frequency response across the load. Here's the marker for the whiteboard. Can you please draw me what that curve looks like? And they don't know. And she said, how can you have a master's degree and not know how an inductor responds to a sweat frequency source? So it seems like, we need to replace that trade school skill set that we used to have in the United States with something. And what I think we're finding is that university education with amateur radio is a great way to do that. So we have 4 professors here tonight who are all using amateur radio in their curriculum. And we have 3 professors from universities in the United States and 1 from Kathmandu, Nepal. And I want to thank Dr. Manu for traveling all this way to be part of this. So a few items here. I want to thank the IEEE IMS team for all the support that they've given us over the course of the last year. It has been a lot of work to make this event come together. As you can imagine, there are 10,000 people coming to this, and all those pieces have to fit. So I want to thank that team. I want to thank Suresh Oza, W6KTM, for helping to be the co-chair and pulling all this together, and for actually being the seed originally of putting together the ham radio event. I want to thank Eric Dunn, K6BZ, for being my sanity, my anchor who keeps me from losing my marbles, and he takes care of all the details that I sometimes forget. I want to thank Ward Silver and the ARRL for all the support that you've given us. You may have seen the article that came out of the ARRL recently about this event. Ward has been our conduit into the ARRL. He's been instrumental in moving this forward, and I really appreciate everything that the League has done. So thank you, Ward. I want to thank Ham Radio Outlet for donations. There will be a raffle which will occur at the end of this panel session. You will be given a ticket by Suresh on your way out the door. Please put that ticket into the bowl, and then we will do a raffle, and Ham Radio Outlet has donated some prizes, and you can participate in that. The reception is out and to my left at the end of the hallway, so please do join us for that. I encourage all of you to take with you this commemorative IMS 2016 QSL card, which you may say, wow, it looks kind of small, but we're green here in California, so we're saving trees by having smaller QSL cards. And they fit nicely in the jacket pocket too, so I like that. And I want to then sort of go directly into our panel. Our first panelist is Dennis Derrickson from Cal Poly San Luis Obispo. Do we have any Cal Poly San Luis Obispo graduates? Raise your hands. Proudly, loudly. Sorry? Current students. Current students, okay, excellent. So Cal Poly, I think, is known for being a very, very hands-on school. They have an excellent program which teaches practical knowledge in engineering. I think you are on what? How many satellites are you up to now? You're on Polysat 8. Are you?
CP9, I think.
So you're up to almost 9.
Probably more than that.
Okay, well. So, they're launching satellites out of the school, so that is certainly not something that you do on paper. So I'm going to let Dennis go into his presentation, and this is going to be one of those cases where I'm going to have to there we go, number 1. There we go. So without further ado, Dennis Derrickson. Thank you.
Thanks, Dave, and thanks for the invitation to come to the IMS. I remember my first presentation ever as a professional was in 1988 at IMS in New York City, so it's a great conference. I've been there many years. So this talk is written by me, but I also have collaborator Stanton Wu, our president of our amateur radio club at Cal Poly, and Marcel Steiber, a previous alumni. So let's see, what are we doing at Cal Poly San Luis in the amateur radio and the EE curriculum world? So I was really fortunate to have arrived at Cal Poly, and it has a long history of amateur radio. So this was one of the original documents of the radio station W6BHZ, and it was, the first advisor was Dr. Harry Wolf. And so long history, and just to emphasize long history, this is Dr. Harry Wolf right now, and he's 107 years old, and he lives in Morro Bay, California, and he does almost daily CW contacts. So I'm humbled by the long history of amateur radio at Cal Poly. I got started in ham radio when I was a kid in high school, and it's been very influential in my professional career. And so selfishly, about 6 years ago, I made the unilateral decision that every incoming freshman was going to get their radio license. So luckily we had a good spirited amateur radio club. They said, sure, we'll do that. And so we set up a date, and when you're a freshman, you're very moldable. You just, whatever the professor says, yeah, sure, no problem. So this is just essentially just a big homework assignment, saying sometimes the amateur radio club will do some learning sessions. Other years they're not quite on top of it, but every year they go through all 400 questions, and about 85% of the students get their amateur radio license in class. And then if they don't get it, then they're allowed to take it at some other local session. But this is actually part of their grade, so they are motivated to get their amateur radio license. We have this big lecture hall, and outside lecture hall they all line up and they have done their paperwork in advance, and they go in, and probably within 25 or 30 minutes almost everybody's done with the amateur radio exam. We get, again, about 85% pass rate, and then we plug them into the amateur radio club. Now I'm not saying that amateur radio here is going to be the transformative experience for their entire 4 years to follow, but for a few people, for a small fraction, it is transformative what it does for them. The radio club they have a rent-a-radio program. They have a lot of activities, so we try to get them incorporated in that. But in addition to that, within courses that I teach and a couple other professors, we are good at trying to incorporate good hands-on radio projects. And when I think of projects to do in the lab, I kind of pour over the amateur radio literature because it's so practical, so inexpensive, and so I just have a selection of things that I've done here in classes. So this is a senior level communications elective, and here I love this technique where you just take a copper PC board and semi-rigid coax and do this dead bug style construction. So this is a digital modulator and digital demodulator that somebody built. In another advanced analog class, there's this book, Experimental Methods in RF Design. Wes Hayward is one of the authors, and right here, Rick Campbell. Can you raise your hand, Rick? He's one of the other authors of this publication right here. And inside that publication, they have this all-analog spectrum analyzer. And so I have the students build the entire spectrum analyzer dead bug construction on top of a big PC board. And it's one of their first big systems projects where they have to troubleshoot everything. And it looks simple, but to get it all to work is actually pretty involved for the students. And that's a great project. There was a article in 73 magazine, which I think is now defunct, but they had a cool little microwave oscillator made out of very simple things right here. So you just take a hunk of copper, and then you get a piece of 14 gauge household wiring and make a little resonator out of that. And then you just take, on the right-hand side here, you have this little transistor, little magnetic coupling loop, and whiz bang, in about an hour or two, you can build a 1 or 2 gigahertz oscillator out of just household parts and characterize it, measure phase noise, and hopefully phase lock it to a microwave to a 10 megahertz reference and learn about phase lock loops. So you can do a lot of cool things with very simple, and this is all inspired by ham radio kind of activities. There's another ham radio person on the East Coast, Gregory Charvat, and he's wrote a book on small and short-range radar systems. And so he has this set of hardware and plans for making a small FM CW radar system. And so I've taken his design and do a bunch of variants on it. And so that's another great hands-on project. You can see this person made helical resonators, and this year they chose to make it on a PC board, but we made other times just on little dead bug constructions with coax interconnections. We have on campus a long heritage of the CubeSat program, so we use amateur radio frequencies for the CubeSat program, and this shows a a satellite system on top of one of our buildings, and our amateur radio club also has a work-in-progress satellite tracking system. The radio club here, W6BHZ, has been very active, and so they're kind of a partner in this curriculum. They have several antenna systems, but they're very active. This shows Colin Hart, which is one of the persons. Colin, raise your hand right here. He's one of our project officers, I think, in the club. And so you can tell you about all the projects he put together here. They're working on the tape measure antenna, which is going to go into a transmitter hunt. On the right-hand side here, we have a transmitter hunt happening on campus. In the middle, there's a picture of the Wildflower Triathlon, and that's it's a lake about 3 miles south of here. And that's actually one of the best activities the radio club has, because at the Lake San Antonio, there really is no communication infrastructure. So the club is tasked with putting up all the repeaters and all the complete communications infrastructure for this event every year. And all alumni come back every year. So it's a great unifying event for the radio club. So summary is we just ask all EEs to get their license, and they do, and they're happy to do so. And this actually a little bit of pride saying, hey, I'm an amateur radio person, when a year before that, they didn't even know what the word amateur radio was. And so for many people, they may just leave it lie, but for a certain group of that people, it's very transformative in their engineering career. Provide compelling club engagement, that's another thing that's important. I incorporate projects from amateur radio since they're so hands-on into the learning curriculum. And I think that you just induce that hands-on culture, and that's a very important part of the college environment. And I think amateur radio can be a real big part of that hands-on culture. So that's my presentation, and I look forward to seeing the rest of the speakers' presentations.
Thank you very much. So I love the idea that Cal Poly requires the licensing. I coined the term the Derrickson Doctrine a while ago, and I've used that a few times when I've talked. And in fact, I encouraged our next speaker to adopt the Derrickson Doctrine at his school, and hopefully at some point in the future we can move down that way. I also want to say that at the Maker Faire last weekend, we had a large contingent of Cal Poly former students, Marcel Stieber, Maria Pikasova, Kenneth Finnegan, and Bob Summers. And they were all fantastic. So I really appreciate them being part of that, and they were very invaluable to what we were doing. So our next presenter is Bob Iannucci. So for those of you who know the name, you know that Bob at one time was the Chief Technical Officer of Nokia Labs, the Grand Nokia Labs in Silicon Valley. And I know a lot of amateur radio people were very excited about the idea of a ham being part of Nokia. And I remember that there were a few people who were encouraging you to add a Morse code function to the Nokia 5190, the candy bar phone, so that we could send audio over the. And I Nokia did clearly not go for that. So I thought, at one time there was this idea that we were going to get Morse code into this new thing that we were called cell phones. So I've had the great pleasure of working with Bob through Carnegie Mellon University and my work with the Dean's Council. Supporting the Silicon Valley campus. We have taught, how many classes have we taught? 3 or 4? So we've had a number of graduate students that have gotten licensed, and I'm always happy to assist Bob with teaching those classes. So without further ado, Bob Iannucci from Carnegie Mellon University.
Thank you very much. Thanks, David and Barrett, for the opportunity to come and talk about something that I'm pretty passionate about, which is combining my interest in amateur radio with the research and educational stuff that we're doing at Carnegie Mellon. So I want to give you just really a brief introduction to what the campus is. No, we're not in Pittsburgh, we're actually in Silicon Valley, and I'll explain that briefly. And then I want to talk about how we're integrating amateur radio into the curriculum for the program. And out of that experience over the last few years, we've sort of developed a few principles that we hope will make their way into all the programs in other universities as well. So here we are. We're in Silicon Valley. We're in the place that was the home of the airship Macon. You can still see that enormous airship hangar 1 in Silicon Valley if you drive 101 North. So we're in NASA Ames Research Park in a lovely building in a campus-like setting. We are currently about 375 students, masters and PhD only. No undergraduates, unfortunately. All the undergraduate stuff is at other campuses, and CMU has a few. But we're masters and PhD, and on our campus, it's 3 programs. There's a software management program that's run by the Integrated Innovation Institute. There's an MSIT program that's run by the INI, the Information Networking Institute. And then I'm part of the Department of Electrical and Computer Engineering, which is the biggest department, claims to be the biggest department at CMU. But on our campus, even though ECE is enormous and covers lots of territory, on our campus we don't cover energy, we don't cover nanotechnology, but we do spend a lot of our time, energy, and focus on wireless systems. And in fact, we're starting a new master's track in specializing in wireless systems from antennas all the way up through apps. And that has had a strong linkage to what we're actually doing with amateur radio. So as a research campus, 375 students, about 40 of whom are PhD, the rest are master students. We have a number of interesting projects going on related to the future of mobile computing and mobile communications technology. I run a project called Cross Mobile, which is a look into where mobile networks are going to go. We're also doing work in 3D art of field understanding. I'll give you some examples of those projects in a minute. I mentioned that we're building a new educational track called Wireless Systems. And we touch on connected embedded systems, low power system on chip. And again, we go from antennas all the way up through apps. And at the center of it, at least for several of us on campus, we are hams. And we sit here as part of the Amateur Radio Club, W6CMU is our call sign. We're called the Wireless CMUSV Wireless Innovators. And we tie together the educational program and the research program by building amateur radio skills and getting our students out in the field. So one of the things that to me ties all this together is an avowed interest in trying to integrate the master's education program with the research program with amateur radio. And in addition to that, as some of us have discussed, Ward and I have had conversations about this recently, in order to make amateur radio really fly on a campus these days with so many distractions, with so many things that attract students' attention, it's really an imperative for the faculty who are involved to have a personal engagement and a personal commitment to amateur radio. I honestly can say, and I would have said this whether Cal Poly was here or not, Cal Poly's an inspiration to me, and in founding our Amateur Radio Society, we've taken the page from their book about how personal commitment has really made a difference in integrating education, research, and amateur radio. And then the third thing, which is sort of my bent, I'm an experimentalist at heart. I try to instill in students that whether they're doing research or whether we're doing education or amateur radio, having an attitude of really taking to the field, building things and trying to get hands dirty and understanding the difference between what the textbook says about propagation and what really happens is an imperative to understanding what's going on. I'm involved in a number of projects related to radio. In the center sits this project that we call Cross Mobile, which is a sort of a new look at LTE networks, and we've had several spin-off projects from that, sort of all around it. And the fact that we have so many related projects also brings another important principle forward, which is the idea of giving students who are interested in radio, as amateur radio does, variety and freedom to explore the areas that are really of interest. So we don't just look at antennas, we don't just look at propagation, we don't just look at software-defined radio, we don't just look at apps, we actually encourage students to take a system view and to follow their interest into whatever aspect or subdomain of amateur radio and research that really intrigues them. I want to say a word or two about the motivating projects. One of them is called Cross Mobile, which is a re-implementation of LTE all in software. So we've given our students the opportunity to really dig in and play with a real honest-to-goodness LTE network as part of research or education or amateur radio. More to say about that later. We've built a software-defined eNode B, and importantly, we've challenged the students to build the front ends, to build the antennas, and to study propagation patterns of real multi-transmitter networks, which is not a trivial thing. And actually what happened when I challenged my students after we put up our first 2-node network, and I said, all right, so what's the coverage look like? Imagine you're the Verizon guy, I don't know. Can you hear me now as you walk around campus? Well, the students actually kind of got tired of walking around campus, and as a result of their interest in radio propagation, they got really interested in putting receivers on drones and exploring the three-dimensional aspects of RF propagation. So we actually now fly a small fleet of drones down at Camp Roberts, where we have the opportunity to access some restricted airspace, where we've done some very interesting studies that have demonstrated, and again I'm talking about students who are hams, that the propagation for RF networks, particularly cellular networks, is not what everybody thinks. It turns out that there are some huge holes in the sky, and we've started a whole line of research that sort of helps to identify the problems that companies like Amazon will be facing when they presume to put drones in the sky thinking that pervasive coverage will come from cellular networks, and in fact it won't. Part of having a good amateur radio club on campus is having some decent facilities. And like most universities, we can't afford a lot of money for the amateur radio shack, so we share our facilities with research. And in particular, we operate an RF van that's built out of an old ambulance. David and some others have seen this, and if you're ever in the vicinity and you'd like to see our portable shack, I welcome you to come and see it. It's an old 2006 ambulance, used to belong to LA Fire, and what we did was we converted it. We put it in a reconfigurable antenna system, so it's got a 42-foot pneumatic mast, great for field day. And then we also built in a roof walk so that you can climb up and bolt antenna assemblies to the top of the mast. And we actually do research from up there. Inside the van, we have a fully software-defined network, and we go from HF to UHF, all the modulation modes that you might care about, as well as ground ops for our drone fleet and our own mobile cloud, as well as a backhaul to the internet with a satellite link. Here we are at Field Day, some alums together, actually working HF using an enormous 100-pound stepper on the top of that 42-foot pneumatic mast. It's a nice thing when you have an 11,000-pound ambulance. The stepper won't tip it over. It's a good thing. It's better than pouring concrete with rebar. We also find, as Cal Poly has found, that tape measure Yagis and fox hunting is a pretty popular thing, and gets students to get familiar with VNA. And to get out in the field and start waving antennas around. So in summary, we find that amateur radio is a really good match to research and education for electrical and computer engineering. The principles that we found to be important in tying it all together is to provide a program that really is integrated, where there's personal commitment to tying these fields together, where we have a take it to the field attitude, and then we provide some variety freedom. And by the way, having some decent facilities doesn't hurt either. I think the challenge for all of us is we need to take the next step in providing the educational material so that these students who actually come in reasonably well prepared for an engineering career can get kicked up into amateur radio really quickly and into the upper ranks of getting their extra tickets quickly. And that's it. That's what's going on at CMU Silicon Valley. Thanks very much.
I want to thank, so Bob referred to the W6CMU as the Amateur Radio Society, which is great because those of you who have seen some of my presentations at Pacificon, you know that I believe that club is a 4-letter word. And I encourage amateur radio groups to not use the term club simply because there's kind of a sort of a negative connotation. I think society or group is probably a better way. So Bob made those very clear. So as I mentioned, I attended University of California at Davis. So Davis was known many years ago for being kind of a sort of a hidden diamond, if you will, in the RF and microwave industry, and a lot of good research, a lot of good instruction, hands-on instruction coming out of there. I had worked in the industry as a technician after I got out of the military, and went back to school later to get my bachelor's. And my teacher, my boss, when I was at Apple, had said, well, if you really want to do hands-on, you really want to do wireless, you probably ought to go to UC Davis. They said because they've got a great hands-on instruction program. Given that you're a hands-on guy, you probably would fit right in. And so I did that. And since graduation, of course, we have Chancellor Katehi, who has come on board at UC Davis, and so, I mean, if you're in the microwave industry, you know the name Linda Katehi, right? How many people in here have heard that name before? She's extremely well published. If you're attending IMS and you're in that industry, you know that Linda Katehi is a very well published author and researcher. So she has done phenomenal work with University of California, Davis, and bringing to the forefront in amplifying what they already had. And I think that when I go to UC Davis for industrial affiliates and I see the student presentations, the one thing that strikes me is that 99% of the presentations that I see on industrial affiliate today are wireless presentations, and they're in terahertz research and millimeter wave. There is a solid hands-on practicum coming out of that school. And Dr. Leo has been on the forefront of that. He had recently gotten licensed, I want to say a couple of years ago. And so he has students as well who are licensed amateurs. And he has some very interesting projects that he'll be telling you about. So I'm going to make a quick change on the slides here. And I remember that you are the PDF. So now I get to remember how to do full screen on the PDF. You do? That's not good. So do page display. There we go. Full screen on. Excellent. So without further ado, Dr. Leo.
Thanks much, David, for the introduction. Quite an honor to be invited here. I would just share some of my personal and partly professional interaction with ham radio. So a little bit about myself. I am an RF and microwave engineer by training. So I did my graduate school at Purdue University in wireless and microwave engineering. And I started as an assistant professor at UC Davis in early 2012. And I do continue doing research in these fields. But I got my call sign in 2014, right, after meeting a bunch of hams in the area and really got inspired. So this is how it all started. I was at the 2012 Maker Faire in San Mateo, and this is where I got to know these great people. Some of them are here. I can see Brian, for example. So this is the 50 megahertz and above radio club. They were showcasing their gears at Maker Faire 2012. And I was really, really impressed by what they were demonstrating. For example, this is Tony, and he is 79 gigahertz radio setup. That was really impressive. And some of the other guys were showcasing 10 gigahertz links. They were receiving signals from some mountains near the area. That was very impressive as well. The other thing that got me intrigued was something I found online, and this was shared by our Cal Poly folks here. It was a small radar design by Greg Charvet. When he was at MIT Lincoln Lab, they actually offered this as open courseware. It's a really interesting design. It's very cheap. At the time, it was about $350, I believe. Now it's a little more expensive today. But you basically put together a pretty well-functioning radar by using these mini circuits components, and you can buy everything from DigiKey essentially. And this radar can do ranging, can measure speed, and you can even use it to do imaging, synthetic aperture radar imaging. So I thought, these are all very interesting, and contrary to what David said about our curriculum, I feel at the university our curriculum has been extremely theoretical. There are good hands-on components, but students learn about how to solve problems, how to solve equations. And you would be amazed at how many students, after, they can perfectly solve transmission line problems, but they don't understand why you need to do 50 ohm impedance matching between two ICs on a PC board. So I thought, we really need some courses that allow the students to get their hands dirty, put things together. So I developed, based on the small radar project, the design into a senior design class. So at our university, our students are required to do a senior design before they graduate. And we sort of divide the senior design into several options. And this one was offered starting in 2012 as a RF-oriented senior design option. So it has been very, very popular. The first year I got 13 students, and within 2 years it saturated the enrollment cap at 36, which is limited by our lab resources. So the course is structured as a 2-quarter course. Our quarters 10 weeks each. The first quarter I walk them through, I give them lectures and also labs. I walk them through building Greg's radar design using mini circuit component and simple baseband circuitry. And the second quarter, this is quarter 1. And the second quarter, so here are some pictures of the radar system. We use one of the signature here is we use coffee cans as horn antennas for both transmit and receive. So at the beginning of the quarter, I buy 20 to 40 coffee cans. I dump all the coffee into our main office, free for students and faculty and staff to pick up, but we use the cans.
Nobody sleeps for 3 days.
Well, in recent years, actually, the coffee has all been consumed by the students in the lab. One of the perks. And in the second quarter, they're required to improve upon this because we have a relatively large enrollment for a lab class. So we sort of need to converge on what they do, right? If they're all doing free-form designs, it would be really difficult for us to manage. So what they are required to do is to improve on their first quarter design, and at the end we do a competition. We go out into the field and see who can measure targets at the largest distance and who can give me the best accuracy, the smallest weight, and the smallest power consumption. So it's a constrained design, and I think that's what we do every day mostly, right? You need to give me a functioning system under some constraints. The constraint may be weight, may be power. Obviously, we have a time limit here because second quarter is only 10 weeks, and you have to do, most of them do a PCB or maybe more than one PCB runs. It takes about 10 days to 2 weeks to get your PCB back, so they have to work that into their schedule. And they're also constrained by money, so each group is provided with $300 budget. They can't exceed that. You can't buy your credits, that's the idea. But that's also a realistic constraint. So, and here is some of the prototypes they have produced. I keep all of these in my office, and for example, the first one, the purple one, was really professionally assembled by hand. So it looks really, really nice. And essentially, anyone who comes to visit me, I show them this, and they would be impressed by how well it's done. So the first one is a 2.4 gigahertz radar. The top board has all the RF components, and the bottom board has all the baseband signal processing component. And the second picture in the middle is a 24 gigahertz radar that has a range for about 20 meters for a human-sized target, and the students used a Infineon 24 gigahertz radar chip. They did the antenna design themselves, so that worked out very well. And the third one is what we actually demonstrated in 2014 at Maker Faire. So we have been participating in Maker Faire since 2014. They demonstrated a working radar system. This is billed as an Arduino shield, so it's an add-on module to Arduino. At the bottom there is an Arduino Duo, which has a 80 megahertz microprocessor, so they do FFT in that one. And on the top there is the Arduino Uno, which controls the signal ramping and setting up the radar system and all that. So this has been pretty fun. I have a video here that I won't show, but feel free to contact me. I can send you the link. And some of our students also did some fun projects since they have all these tools to put things together. In 2012, we participated in the student video contest hosted by MTT Society. These students basically use their transmitter and receiver to visualize microwaves. Okay, so microwaves are invisible, you can't see them, but if you have a detector, a transmitter and a detector, you can actually show, this has to be phase coherent, you can actually show the different phase that you're detecting as you change the distance between the TX and RX. And they did a long-time exposure in a dark room where you can show signal strength, which is visualized by LEDs, that is proportional to the phase variation. So they did the picture in the middle shows both phase variation and amplitude variation as you change the distance. And the third picture is basically a double slit experiment where you can see interference patterns. So these are two transmitters and one receiver. You move the receiver around to map out the phase. So this has been, and these two guys, the team won first place in 2012's competition. So this has been, my interactions and experience with ham radios. We don't really build ham radio equipment, but I think we share the same mentality, is to allow the students to be exposed to more hands-on projects, and I find it really, really valuable for the students. And that's what the students told me, that this is the icebreaker for their interview. Right? When they go to job fair and hand in their resume, and every employer would ask them about this, and they can spend a good 30 an hour to talk about all the details, all the difficulties they faced in putting the working system together. So I think it's been really, really valuable to this. Okay, so we'll here.
So Dr. Leo talked about the dark room, and it's probably one of the few dark rooms that are actually left in the world. It was used, when I was there, we used it to expose copper-etched PCB as part of the EC132 sequence. Is Dr. Branner here? I thought Dr. Branner might join us tonight. So it's an interesting connection to how I met our next panelist. Suresh Ojha, W6KTM, and I were in Dr. Branner's 132 sequence in UC Davis. He left, went to Nepal, which is the country of his ancestors, and began working teaching at the university. Years later, through amateur radio, we began talking on the air. We just happened to meet each other on a repeater in Silicon Valley. It turned out a couple of things were interesting. Was this one, we were both in the test and measurement industry at the time, working for competitors, but it also turned out that we knew each other. And in reaching, kind of reconnecting with him, learned about what he had been doing over in Nepal. So he asked me to get involved in a project that was called Radio Mala. And Radio Mala is a project that's part of a Nepali diaspora that people were trying to encourage the country of Nepal to allow more proliferation of amateur radio. Now, for those of you who know the history of Nepal, they only recently ratified a constitution last year. They came out of a civil war only recently. It was 2008, if I remember correctly. And there were some concerns about the use of amateur radio in the country, that it might be something that would be used by rebels or by troublemakers. So the government has had to be encouraged to allow amateur radio in the country. So through that group, being connected with Dr. Sanjeev Pandey at Tribhuvan University in Kathmandu, Nepal. Now there have been some efforts to get Nepalese licensed to have it be more open and start breaking down those. The caste system is not legal in Nepal, but it is still socially somewhat still there. So there's some challenges that have to be overcome. Of course, in the course of doing that, in April of last year, we had the massive earthquake, the Gorkha earthquake, which occurred. And so it became very imperative upon us that we do things like get handheld radios that had been sitting in customs for weeks out of customs so that they could be used in the recovery effort. And there was some pressure was applied by some meetings that Suresh and I had through government agencies trying to encourage the Nepali government to be more open about allowing these things out. And so Dr. Pandey has really been an instrumental force in making this happen. I don't want to call him to the stage and hear his story. So without further ado, Dr. Sanjeev Pandey from Tribhuvan University at Kathmandu, Nepal. One second, I'm sorry.
Good evening, ladies and gentlemen. First of all, I'd like to thank IMS, David, and Mr. Surya Soza for bringing me down all the way from Nepal. It's a real honor to be here and to present in front of you. So, David, thank you for the introduction also. And today, I'm going to talk about amateur radio to enhance in engineering education, and basically I will be talking about what we are doing in our university, right? So I would like to start with my introduction. So I work as an assistant professor in Department of Electronics and Communication Engineering, Pujo Campus, Institute of Engineering, Cleveland University. I am a master's program coordinator, computer system and knowledge engineering, as well as I am deputy director of Information and Communication Technology Center here. And for you, this is my university, its logo, and the building we have there. So this is a slight overview of my talk. So all of them have started. So since I come from Nepal, so some of you may not be familiar with Nepal. So I want to go with first I would like to start with the introduction to Nepal. Then I want to talk about ham radio in Nepal. And then I want to talk about the importance of university for the ham radio, importance in the university education. Then I want to talk about engagement in ham radio, and then how did we encourage students to become amateur radio, and last I want to conclude by practical example why amateur radio knowledge is important. So at first I'd like to start. This is the greeting we say Namaste. This is what we use in Nepal. And where is it? So it's in the South Asia between China and India. So you can see it at the map. And so Nepal is known as land of Gorkhas. And then it's most popular for the Himalayas. It has 8 out of 10 world's highest peak are in Nepal. And then it is for of course, Buddha was born in Nepal. And it is the second richest country in water resources. So these are some of the snaps from the birthplace of Lord Buddha. And in the next slide you can see this is the Mount Everest. So we have. So with that, I'd like to start ham radio in Nepal. So ham radio in Nepal was formally opened in 1993 only. So before 1993, Father Moran of St. James School, he was the only one who was using ham radio, and he was given special ordinance by then King Mahendra to use it. And in 1993, so radio communication license rules were enacted, and first tests under the rules were conducted, and there were only 3 operators. So these were the 3 people who got the license. And another exam was held in 1996 and 97. Only 2 operators got license during that time. And then after that, there were no exams held for 13 years. So it was in 2012, I came back finishing my PhD degree. So back in 2003, Mr. Surya Soza was my mentor, in RF and microwave engineering course. So I asked him, what should we do? And he told me, okay, let's encourage your students to the amateur radio part. So that's how I got into the amateur radio actually. So a small background, so why you need university engagement in ham radio? So previously ham radio was only accessible to people who were wealthy in Nepal, and the government were little aware about the internationally accepted regulations. For example, UHF and VHF frequencies were not available to the novice hams, the ham operators who get the license. They were only available to the advanced operators, and whenever they want to change the regulation, it was not publicized. They do it in the closed door. And so this was the exam that was held in 2011. So you can see me in the blue sweater, because I thought when he told me you should encourage your students, I thought if I am not an amateur radio operator, then how can my students will be encouraged, right? So I thought it will be first I will take the exam. So I took my 10 students with me, and along with them I sat and gave the amateur radio exam, and I passed it. Then in April 2012, so this is Global Neblis Professional Networks. So they built the first repeater in the history of Nepal. So we have a gentleman here, Rob Rollins. He was there in Nepal to train us. You can see this one. Then this was installed in one of the NGO's building, which was in which has the ruggedized building structure. And as soon as this repeater was installed, so the UHF, we came to know that the UHF and VHF frequencies can be used only by the highest ham radio, advanced ham radio operators. So there were only 5 of them that time. So I, in the front, from Cleveland University, I went to the ministry and requested them, okay, we have to alter this policy, right? So it took me 6 months, but actually at last I got successful in granting UHF and VHF frequencies to all the ham operators. So the main thing why university should be engaged in involvement in ham radio is they can provide proper guidance to the government in terms of international norms and regulations. So in Cleveland University where I teach, so I teach in the electronics department, and we have 2 courses in electronics department, bachelor's level, and in the master's we have RF and microwave engineering. I teach electromagnetics in bachelor's level, so that's in the 3rd semester. So I encourage those students, it's not incorporated in the course, but I encourage them, and this time out of 48 students they went and gave the exam. And in masters we have 20 students. I encourage them also, and there is another program disaster risk management. So they are not from the electronics background, so it's from any field you can join this program. I teach the disaster informatics, so I took students from there also to take the exam. So this is the picture. This is the picture of when the Rob came to us and trained us. These are my students, and this was in 2014. After 2011, the next examination was held in 2015, so you can see the picture on the left, the people were taking written exam. On the right, so they are taking Morse code exam. So in Nepal, still the Morse code is required to get an amateur radio license. And this may be little this is the building where I work. I'm the deputy director, so this was our first installation of HF antenna with some of my students on the right. And this was the first transceiver we got it, and as you can see, it was donated by Whiskey 6, Victor Bravo. And this was our first experience, so that was the dipole antenna, multi-band dipole antenna, and this was our first instruments we get hand on. So as soon as we installed this, so the students were very excited, they were reading transmission line theory, antennas, baseband electromagnetic theory, but they were not applying it in the practical field. So for them it was a transition from simulation to a real hardware where they can check how the hemispheres work and other kinds of things. So another one is Keysight donated Nepal's only RF and microwave laboratory. So this was actually he came in 2003 and set us a lab in the RF and microwave laboratory, 56 kilotangle mics, Bresosa. So, and now the students use these facilities where they have spectrum analyzer and they measure ham radio spectrums and they analyze impedances using network analyzer. So, use of ham radio in disaster management. So I told you we have disaster risk management, and it's very challenging to get those people on board. So actually I tell them okay, since you are working in disaster field, this will be fit for you. So, and they join us. So, and this is we have chronic disasters, so earthquake, fires, landslides, floods, and it's really necessary to have ham radio incorporated into our course. So this is just, I don't want to talk about what we did in earthquake. You can see it we can talk in the other sessions there. So we send the reports from Nepal to master operators using HF radios, and we also install the VHF repeater. So, and this is from the same earthquake, since it doesn't we volunteer to do for the ambulance dispatch and other things. And these are some of the slides we built we set up the VHF repeater in the middle of the earthquake. We were having aftershocks that time, it was between April 25th and May 12th, where we had another earthquake of 7.3 magnitude on me too also. This was the first repeater, so now it's in this position, and I don't know, David said no club, so this is my 91 SP repeater, and that's the VHF frequencies, and we are on Ecolink also, and on IRLP also. You can talk from here, and these are my students like who always with me, and this is like some of the things we did like during the earthquake, where we went to the hospital and tried to help them. So like just to summarize, like so universities can play a key role in advancing amateur radio regulations. Before, like the cost of amateur radio was very high for us, like we have some like backup, so I don't think it's a barrier to engage the cost of the equipment is not a barrier. And the main thing is like engineering students find an intuitive transition from design, test and measurement cycle with ham radio if it is embedded into their curriculum. So I think like we have to integrate amateur radio into our university curriculum, and this is like our Ecolink answer. With that, I'd like to conclude. Thank you so much.
Okay, thank you. That's very, I mean, the notion of sort of creating, we take it for granted, right? I suppose, certainly as Americans, we take it for granted. It's just been part of our lives, and you know, we don't think about the idea of having to create a hobby and getting government approval to use a handheld. So I think that it's great work that is being done at Nepal, and I commend Dr. Pandey and the team for everybody who's been involved with bringing the amateur radio to Nepal. We have a very short amount of time for questions, although given that we're going to have a social afterwards, I hope that you will all engage with the panelists during the social as well. We do have 5 minutes for questions. If anybody would like to come forward with a microphone, you may do so now. You've stunned them in silence. Does anybody have any questions about what we're going to do next? So some of you came in late. I want to recap my notes from earlier. Give me 1 second here. Okay, the social is out in the hall. You go out to my left down the hall. There's food and drinks down there. I do hope that you folks will join us. I again would like to thank the IEEE IMS team for all the support that they've given us. It's very complex to put on events like this. They've done a phenomenal job at making all the pieces fit together and work smoothly. I would like to thank Suresh Ojha at 6KTM, Barrett Dunn, K6BDZ for being part of the co-chair team for this event. Ward, again, thank you so much for your support, the league support. Ham Radio Outlet provided some giveaways. Now, if you didn't hear this earlier when you came in late, Suresh is going to hand out raffle tickets. You will put the raffle tickets into the decorative bowl. We'll take the raffle tickets from you on site. We'll then raffle. You will get to potentially win some fabulous prizes. And we have QSL cards. So commemorative QSL cards for everybody. So if you can look on your table and see this, these were done by the IMS committee. They're provided by them. Rare, keep this. And if you have brought QSL cards of your own, please display them on a board. There's a board out in the lobby where you'd like you to put your QSL cards on that board. I would like to thank the panelists. Dr. Derrickson, Dr. Iannucci, Dr. Leo, Dr. Pandey, thank you for what you're doing. Thank you for being part of this event. And I would like to issue a challenge to the panelists. So I've decided what we're doing next year for Maker Faire. So I would like to host the Amateur Radio and University Maker Faire next year. And I will take care of all the details. You provide the students and the genius and bring your projects, and we'll make it happen. I know that's a challenge for you, Dr. Pandey. So, especially for you. But I would very much like to see a great turnout next year, and so to make it good. Thank you again for being. Let's give them a hand.
Appreciate you sticking around through the program today. Hope you enjoyed learning about Maker Faire and IMS. There's so much knowledge to be gained from our community as amateur radio operators. We're going to continue to work that out here on the show. Don't forget, next Tuesday, the very first inaugural episode of Ham Radio 360 Workbench Podcast. Don't want to miss it. It's going to be a lot of fun. And go ahead and start thinking about your questions, your ideas, your maker, your DIY, the stuff that you have questions about you'd like addressed on a program. That's going to be the place for it. It's Workbench. You can find, I'm putting up links now on the show. There's a tab there on the top of the website, hamradio360.com. Hit the Workbench tab. It'll give you some information there as we ramp up for the program's release next week. There's no new RS feed. You don't have to go find it on your player or in iTunes. It'll be right here. It's just a subsidiary of what we're doing every other week, now doing every week on Ham Radio 360. Totally appreciate you being here. Hope you're sharing this with your friends. If you need a hat, if you need a shirt, stickers will probably be up in the next couple of days. Got patches on order as well. If you want some Ham Radio 360 swag, click the shopping link, top of the page. Click the link, and your stuff's there. Thank you so much for listening. I appreciate every one of you. God bless you, and we'll catch you next time. 73, y'all.
Thank you for listening to Ham Radio 360, brought to you by mtcradio.com. For more information about the program, visit hamradio360.com. Till next time, 73s, y'all.